Welcome to Formula 1 Maths. This is past exam questions 003 for IGCSE. We've got 3 questions to answer. Question 1. Given that x is equal to 16 times 10 to the power 20n, where n is an integer, find an expression in terms of n for x to the power 5 over 4. Give your answer in standard form. We are going to use the loss of indices to solve this question. By substitution, x to the power 5 over 4 can be written as 16 times 10 to the power 20n, all of that raised to the power 5 over 4. But 16 is 2 to the power 4. So, x raised to the power 5 over 4 is equal to 2 to the power 4 times 10 to the power 20n, all of that raised to the power 5 over 4. We are now going to use the loss of indices, specifically rule number 3, to simplify this expression here. 2 to the power 4 times 10 raised to the power 20 and all of that raised to the power 5 over 4 can be simplified to 2 to the power 4 times 5 over 4 times 10 raised to the power 20n times 5 over 4. We can now simplify the fractional indices as follows. 4 goes here 1, and 4 goes there 1. 4 goes here 1, and 4 goes into 20n, 5n. So the whole expression becomes 2 to the power 5 times 10 to the power 25n. So x to the power 5 over 4 now becomes 2 to the power 5 times 10 to the power 25n. But 2 to the power 5 is 32. So x to the power 5 over 4 becomes 32 times 10 to the power 25n. The question requires us to give our answer in standard form. This expression here, as it stands, is not in standard form because 32 is bigger than 10. So we need to write 32 in standard form, and 32 in standard form is equal to 3.2 times 10 to the power 1. So we can now replace 32 by 3.2 times 10 to the power 1, and we are going to get this. There's a power of 1 here, so we can now simplify 10 times 10 to the power 25n using the laws of indices, and on this occasion, rule number 1, and that means we are going to erase 10 to the power of the sum of 1 and 25n. And so we end up with 3.2 times 10 to the power 25n plus 1. And that is the answer required for question 1. Question 2. The diagram shows the design of a logo made up of a circle and 2 triangles. A, B, D, and F are points on the circle. ABC, CDF, BDE, and AFE are straight lines. Work out the angle X, showing you're working clearly. Let's start by letting this angle here be represented by the letter Y. So angle BAF is equal to Y, and angle ABD, this angle, be represented by the letter W, as follows. If we now look at triangle AFC, we can see that X plus Y plus 25 will give us 180. And so we have this equation here. And if we rearrange to make Y the subject, we are going to get Y is equal to 180 minus 25 minus x. This simplifies to 155 minus x. So we can now replace y by this expression to get the following. We now turn our attention to triangle ABE, and we can see that w plus y, which was here, plus 63 is equal to 180. If you make w the subject, we're going to get w is equal to 180 minus 63 minus y. And this can simplify to w is equal to 117 minus y. But we have already found the value of y to be 155 minus x. So we can replace y with 155 minus x to get the following. If we simplify that, we're going to get w is equal to x minus 38. So we can replace w here with this expression as follows. One of the circle theorems states that the opposite angles of a cyclic quadrilateral are up to 180. And as you can see, A, B, D, F is the cyclic quadrilateral, and these angles here, x and x minus 38, must add up to give 180. And so we get this equation. We can now solve this equation for x as follows. 2x minus 38 is equal to 180. Rearrange to get 2x equals to 218. Solving for x gives 218 divided by 2, and that finally gives us 109 degrees. And so that's the value of x. Question 3. A particle P is moving along a straight line from a fixed point O, which lies on the line. At time t seconds, the displacement s meters of P from O is given by s is equal to 5t cubed minus 3t squared minus 4t. A. Find the speed of P after 2 seconds. B. Find the time at which the acceleration of P is 39 meters per second squared. So for A, we are given that the displacement s is equal to 5t cubed minus 3t squared minus 4t. To get the speed, we need to differentiate the displacement. And when we differentiate the displacement, we get velocity. But velocity is the same as speed. The only difference is that speed is a scalar quantity and velocity is a vector quantity. So if we differentiate displacement with respect to t, though we get velocity, we can regard it as speed as well. So if s is equals to 5t cubed minus 3t squared minus 4t, differentiating will give us ds dt, which will be equal to v, and that will be 3 times 5, which will be 15t, and reduce the power by 1 to get 2 here. We do the same thing with the second term. 2 times minus 3 minus 6t. Reduce the power by 1. We get 1. And do the same thing for the third term. We get 4. So this is the velocity. But as explained earlier, we can regard it as speed. So that means we get this equation. But we want the speed when t is equal to 2. So all we do is substitute 2 into this equation. And if we do that, we are going to get the following. Simplify to get this. And finally, we are going to get 44 meters per second. B. We have now established that speed is equal to 15t squared minus 6t minus 4. To get the acceleration, we need to differentiate speed or velocity with respect to time. And so v is equal to 15t squared minus 6t minus 4. The acceleration will be given by dv dt equals to 30 t minus 6. And so the acceleration will be given by dv dt equal to 30t minus 6. But we want a time when the acceleration is 39 meters per second squared. So it means we can equate this expression here to 39 meters per second squared. So let's go and do that. We're going to get this equation. Rearrange to get 30t equals to 39 plus 6. Simplify to get 30t equals to 45. Solve for t and you're going to get 45 over 30, which can be reduced to 3 over 2. And that means the time when the acceleration is 39 meters per second squared is 1.5 seconds. And this is the end of this session of past examination questions. Thank you for watching, and I'll see you in the next video.